Hey guys, yeah, thanks all for joining. I'm going to be super quick because there's lots of great stuff to get through from the Kiel team. Just to say, yeah, Tech, we've been sort of proudly associated with the Green Gown Awards for over 10 years, and of the 2030 Climate Action Award for the last 4 to 5, for which I was really pleased to be part of the team that awarded the Kiel team with a highly commended in last year's Green Gown Awards. Why showcase this one? Well, you're going to see for yourselves in a few moments. But we all know that energy use, we all need to use energy a lot smarter in the future. And the way that Kiel have demonstrated smarter energy use and the integration with some quite complex energy systems we felt was a real beacon and something from which we can all learn. So hopefully that's why you're all here. As I said, I'm going to hand over to the Kiel team to introduce themselves and sit back and enjoy the presentation. So over to you, Julian, I think.
Okay, thank you. Thank you. Just to introduce myself and the rest of the team members today, I'm Julian Reid, Partnership Development Manager at Kiel University. Formerly, I was the Programme Manager for the Smart Energy Network Demonstrator, which established the project and delivered the research that we're going to hear about today. Just handing over to Matt for his introduction.
Good afternoon, everyone. I'm Matt Dean. I'm the SEND Research and Innovation Manager. I've worked on the SEND project now for over 4 years. Previously, I was involved in the setup, commissioning and testing of the SEND systems, also helping students, academics and researchers gain information from the system, showing them how to use them. I'm still involved in the day-to-day operation and maintenance of the systems, but I've now moved over to the research and engagement side of the university, so focusing more on external engagement, looking at how other organisations can utilise the demonstrator, continue to improve it, and partnering with them to apply for grant funding for projects. India.
Okay, thanks, Matt. Hi everyone, I'm India Ford. So I'm currently the Projects and Placement Manager for the School of Geography, Geology and Environment at Kiel University. Formerly, I worked with Matt and Julian as part of the SEND project team. I started off as a SEND MSc researcher, worked on 2 projects following my MSc in Environmental Sustainability and Green Technology at Kiel University. I then engaged with businesses and supervised student projects alongside the team and helped them. Yeah, back to Julian.
Okay, thank you. So in terms of today's presentation, we're going to cover 3 main aspects, really. First of all, a little bit about the history of the project, where it came from. But then I'm going to cover some of the technical aspects, which Matt will pick up. We're going to cover a little bit about the businesses we've engaged with and some of the achievements. And then for us, what has been a real achievement is the work that we've done with industry and the work that we've done with students and how they've progressed into some absolutely incredible jobs as a result of the Smart Energy Network Demonstrator and the opportunities it's offered them to deliver projects. Next slide, please, Matt, if that's okay. A little bit of the history. So the project, in terms of planning, dates back to 2008. And when I look at Kiel University now compared to how it used to be, and those that have visited the campus will recognise the number of developments which have taken place basically on an annual basis. And in the last 4 or 5 years, while I've been in operation at Kiel, I've seen a data science centre delivered, a veterinary school in collaboration with Harper Adams, a business school, a new hotel facility would advance the technology. So what we're seeing is growth, not just in terms of the university science park, but also in growth in terms of student numbers and growth in terms of the number of businesses that we have in operation. We have some incredible businesses on a science park as well. Companies like TIA, who produce the eye drops, a big multinational, huge organisation. Biocomposites, Charles Rivers, organisation that produced the vaccine for COVID, and so we recognised through all of this that our energy demands were going to be increasing as we grew and developed a science park. So we had to take an order to develop our facilities to manage that energy growth, which was started off originally by our estates team in terms of their thinking and what we needed to do, but what actually came to is actually when we started to secure the investment, we started to realise that there was an absolutely massive opportunity in terms of taking on some of the main sustainability challenges, but also starting to look at the technology and how we could use that technology as a demonstrator. So the timeline that you see there is some of the major waypoints forward for the university. But as we move through this timeline, we secured investment, and the investment for Smart Energy Network Demonstrator came from the Department of Levelling Up through ERDF and the Department of Business Innovation to secure business support and advice. All the projects started to combine with the Smart Energy Network Demonstrator, which was our own generation in terms of the wind turbines and solar panels and batteries. We then combined that with the opportunity to deliver hydrogen from the site. And each and every time we delivered a project, it brought more skills and expertise to the university's team, and also gave us a greater profile in the marketplace. So next slide, please, Matt. So the Smart Energy Network Demonstrator itself was a £16 million programme, funded, as I say, by BEIS and funded by the Department of Levelling Up. We were tasked to deliver some key outputs. The key outputs were business support, so we delivered just over 55 business support opportunities to research opportunities to start your business, but also to deliver big carbon savings. So we were tasked at delivering just over 4 tons of CO2 each year, which we achieved through the duration of the projects, and that was against the baseline originally set. The project itself, we worked with Siemens and some big suppliers to enable us to deliver the infrastructure. But as the project moved forward, we saw that it was actually making connections across the globe, and we saw businesses and governments to come to visit Kiel because they wanted to see how we adapted and delivered that technology. So I'm going to pass over to Matt, so Matt can talk through the facilities that were put in place on the campus. Thank you.
Thank you. Okay, so I am going to start with a few facts and figures about the campus. So we're quite a large campus, approximately 600 acres. We've got a wide range of mixed-use buildings, so academic, residential and commercial. Around 12,000 staff and students on campus each day, and with the size and scale of a small town. So this is what made us particularly suited to the SEND project. Yeah, we are at that scale, and it enables us to test all these new technologies, but also then scale those up to kind of city level, possibly even country level. So the low carbon energy generation park, it's a nice aerial view there. It took us over 2 years to get planning permission for this. It was helped a lot by the fact that the local council declared a climate emergency midway through the application. We were extremely lucky to get planning for the turbines especially. As far as I'm aware, we were the only 2 onshore wind turbines in England to start generating in 2022. The last few days, hopefully all that's changed. I know there's been some new policy released, so hopefully we'll see a bit of a change in the regulations on the wind turbines. So what have we got at Kiel then? We've got a 1 megawatt peak, 2 megawatt hour lithium iron phosphate battery. We've got 2 wind turbines, one 900 kilowatt, one 800 kilowatt. So we've got a maximum of 1.7 megawatts of wind generation. We've got 12,220 solar panels. So they produce 5.5 megawatts DC. Once they ran through the inverter on site, we get a 4.4 megawatts maximum generation on the AC side. So that gives us a combined total maximum generation on a really windy, really sunny day of just over 6 megawatts. So this is the SEND control room. So this is where I'm lucky enough to call my office. This is where we monitor the energy generation and the energy use around campus. This is where we've got the software based that I'm going to show you today. So SEND consists of 2 main pieces of software, SP5 and DOP. So SP5, Spectrum Power 5, DOP stands for Decentralized Energy Optimization. There's a number of other packages that we haven't got time to go through in this presentation, but these are the 2 main ones. So I'll start with SP5. That deals with our HV network and our renewable generation. So on here we can see a geographical substation view. We've got around 27 substations on campus. So each of those white boxes that you can see is an individual substation. The green lines that are running around the campus, they're our underground 11 kV cables. So they're the kind of main arteries that power all the buildings on campus. At the top there, substation 13 is our point of common coupling with the national grid. So when we are not generating enough from the renewables to completely fulfill the campus load, that's where we import anything else that we need from the grid. When we're generating enough to cover the campus load and we have an excess, that's where we send that excess back out to the grid. So this is the SLD, the single line diagram. So this shows those same substations, but allows us to see real-time information on what's going on with the network. So things like switch status, whether the switches are open or closed, which cables are energized or de-energized, and the layout of the network, so how the individual substations are actually connected to each other on the site. Again, at the top there, we've got substation 13, the point of common coupling. So if you zoom into a particular substation, you can get more detailed data such as voltages and currents. This is just an animated GIF that I've got on the screen at the moment rather than the actual live data. But if we were in the control room, you would actually be able to see the live data of exactly what's going on in particular substations. So as part of the SEND project, we retrofit remote actuators onto the front of the switchgear. So that's an example of some switchgear there in the substation. We retrofit remote actuators onto the front and also added fault passage indicators. So what those pieces of hardware enable us to do is something called FLISR, which stands for Fault Location, Isolation and Service Restoration. So in an old style manual system, if there was a break in a cable on the sides, so if, for example, somebody was out in a JCB digging and they cut through one of the cables, you would have to go through quite a laborious process of waiting for people to tell you that part of a building had lost power. You'd have to send engineers out to find exactly where the break was, which buildings were affected. You'd have to manually create a switching schedule, and then you'd have to send engineers out around the site to actually perform those switching operations. The advantage over having these fault passage indicators and the actuators is that we can automate this whole process. So the system is constantly monitoring these substations. It can tell if we've lost power in them for any reason, and it can automatically switch the network to keep as many buildings online as possible. So that's much faster, and it also is much safer as well, because you're not having to send people into those substations and actually stand in front of the switches to operate them. They can all be done from the safety of the control room. We don't actually let the system completely automate itself. There is still a step in there for safety. So once it's proposed a switching schedule, it does need somebody who's HV trained just to sign that off before we actually let it reconfigure the network. SP5's also got something called a study mode. So basically this is kind of like a digital twin. So we can use this to simulate the effect that performing switching operations will actually have on the network. So if we've got any planned maintenance, or if we're adding another substation, for example, and we're going to have to start switching, we can actually put the system in study mode, perform those switching operations, and we can see exactly which parts of the network are going to be de-energized and make sure that there's no unintended consequences. So this is probably one of the most interesting screens of SP5. Again, this is just an animated GIF rather than the live information. But this is the power flow screen of exactly what's going on around the campus. So on the left-hand side here, you can see the PCC, our point of common coupling at substation 13. We've got the campus load there on the right-hand side. So at the time that this GIF was taken, it was hovering around 2.5 megawatts. So that's the power usage of all the buildings on the campus. PV generation at the time was quite good. We were getting around 3 to 4 megawatts of generation. So that arrow is indicating that that PV generation is feeding into the Kiel network to be absorbed by those buildings. Wind generation, we got around 200 kilowatts. So again, that's feeding into there. The battery, we were slightly charging at the time. So the combined PV and wind generation, we were over 3 megawatts. The campus load was only around 2.5. So as a consequence, we were exporting back to the national grid. If the combined generation was less than the campus load, that arrow would switch around and we would start importing in from the grid and the shortfall. So because we're quite solar heavy, our maximum generation tends to coincide with the middle of summer when the students aren't here. So the campus load consequently is at its lowest during that time. So especially in the summer, we can have lots and lots of excess generation. One of the challenges that Kiel faces, which is a challenge that's faced up and down the country, is that the infrastructure outside of Kiel is not capable of handling massive amounts of export. So we've actually got an export limit of 1.5 megawatts on what we can send out to the national grid. So to handle that, we've got this sub 1 second monitoring in Send to constantly monitor that export. If we breach that limit to the national grid for more than 5 seconds, they will actually trip remote breakers in the substation down at the renewable site. So we lose generation on the wind turbines, the solar panels and the battery, everything goes off. It takes around half an hour to reset all those devices and get them back generating again. So we do everything that we can to try and stop from breaching that limit. So that's where Send comes into play. As I say, it's constantly monitoring that export. And if we get over 500 kilowatts export, we'll start dispatching demand response assets around the campus. So that's things like turning off the gas boilers to heat the hot water and instead turning on electric boilers. So we've got 3 500 kilowatt electric boilers around the campus. They're very fast reacting, so they're an ideal asset to try and absorb that generation. You also get a carbon saving there as well, because obviously you turn your gas boilers off and running the electric boilers from green electricity. We also control lots of other assets as well, so things like air handling units in buildings, air conditioning units. So all with the aim of kind of artificially inflating the campus load to absorb as much of that energy as we can in useful ways. So next I'm going to move on to DEOP. So one of the main purposes of the SEND project was to enable the data to be accessible. So SP5 that we've just been talking about gathers lots of really high resolution data about things like the substations, the renewable generation. But because of the sensitivity of that software, you could literally turn the campus off with it. It's only accessible from within the control room, which is why I've been showing animated GIFs on the presentation. So to enable access to the data, we've got a system called DEOP. It's a cloud-based platform, so you can log in from anywhere in the world. We can create pretty much unlimited user accounts. So this is where the students, researchers, academics can log into and get access to not just the renewable information, the substation information, but we've also got hundreds of gas and electricity meters from around the campus that feed into here, and things like the EV charging information as well. It's very flexible. This is just one of the many screens in there. Once somebody's got an account, they can create their own screens as well, build them up from individual widgets, save reports that they've created. They can add those onto the home screen. You can really tailor the system to what they're particularly interested in. So DEOP also controls assets as well, but in a slightly different way to SP5. So whereas SP5 was controlling assets to turn them up to absorb excess renewable generation, DEOP actually controls assets to turn them down in response to the grid carbon intensity. So I'm sure most of you on the call will be familiar with the national grid carbon intensity, but this is just an example screenshot. So at any given time, the electricity for the UK grid is produced by lots of different sources. The proportion of using of those individual sources affects the grid carbon intensity. So at this time when this screenshot was taken, we've got nearly half of the generation was created from gas. We've got a small amount of coal, nuclear, wind, solar, biomass, imports from other countries. So the proportion of those that we're using dictates how much, what the carbon intensity is on the grid. So that half of gas is responsible for nearly 3/4 of the carbon output. As a consequence, we've got 244 grams of CO2 being released into the atmosphere for every kilowatt hour of electricity that's being produced. So that's classed as a high grid carbon intensity. So the national grid not only does this real-time grid carbon intensity, it also does a forecast a day ahead. It's that we import into the DEOP system to control the assets. So this graph here just helps to explain that a little bit. There's 6 buildings that we do this carbon saving on. This one's for the library. So on here we've got the grid carbon intensity forecast. So that's the day ahead forecast, the green line there. As you can see, it fluctuates up and down during the day, dependent on what renewables we've got on the grid, what fossil fuels we've got on the grid. Next, we've got building flex. So the system is constantly calculating how much it can save by turning down all of the assets in that building that we've got under our control. So that's the building flex there. We've got a building carbon intensity limit. So that's a limit that we set. We've got that set at 0.2 kilograms of CO2 per kilowatt hour at the moment. And the purple line there is the flex requested. So you can see while the grid carbon intensity is quite low, the grid's quite clean, it's under that limit that we've set for the building. Even though we've got flexibility available in that building, we're not actually trying to use any of it. So we're not trying to actively turn anything down. As soon as we breach that carbon intensity limit, and for that duration there, we start calling off the maximum available flex in that building. So basically just trying to turn down as many assets as we can while the grid is at its dirtiest. So as I mentioned earlier, we also have EV data that comes into DEOP. So we've got 20 EV charge points at what we call the green zone, which is the main EV charging car park. We've also got a further 20 EV chargers at two new buildings, IC7 and the vet school, which we're hoping to get into DEOP shortly. So we've got full visibility in here of exactly which charge points are in use, how much power is going into the vehicle, how much that's costing us. We can also run historical reports as well. But basically having this visibility gives us the chance to do smart charging on those EV vehicles in a similar way to turning down the assets in the buildings. We can use the grid carbon intensity to actually defer the charging of the vehicles to the cleanest part of the day. So we've got a mobile app users can download. They can enter into that app their battery capacity of the vehicle, their current state of charge, and a required state of charge by a certain departure time. Once the system's got that, it can then work out how long that charge will take to get, and as I say, defer that to the cleanest part of the day. So this is just an example of a charge that I did on my own vehicle. So again, you've got the grid carbon intensity forecast there. That was the arrival time when I came onto campus, so around 8:30. The departure time that I set into the system was around 2 p.m. and that's the EV charging power. So you can see there the grid carbon intensity when I first connected the charger was very high, the grid was dirty, but because this is a forecast, it's effectively like the system can see into the future, and it knew that the grid was only going to get cleaner throughout the day. So it blipped the charger on, immediately switched it off, and then deferred that charging until as late as possible to get that charge in during that clean part of the day. Finally, just to show you a typical week of summer generation on the campus. So the orange line there is the campus load, the green is the wind generation, the dark purple is the solar, and the light purple is the combined wind and solar generation. So that just gives you a really good idea of just how closely aligned our generation is, especially with having the solar is really suited to the campus load. We're getting the peaks and troughs coinciding at the same times. Anything above that point there is when we've got an excess and we're actually exporting back to the grid. So now I'm going to pass back to Julian.
Thanks, Matt. So the presentation that Matthew's just delivered, we do deliver variations of that presentation at workshops and visits to the Keele campus. And what we were originally tasked to do was to support regional business with their aspiration to support their energy transition. We found ourselves that the programme itself supported our resilience, our energy security, and also our carbon reduction. And that message we passed on to a regional business. But as a demonstrator facility, we recognised we'd got a greater call. And we were starting to receive visitors from all manner of sectors, from not just in the UK and locally, but sometimes internationally. And to date, we've had just over 30 delegations from international business and international visits for the Department of Business and Trade to come to Keele to learn about the infrastructure that we've implemented and to learn about the research that we've done alongside it. And what we've done is pass on that positive message to many of those visitors that have come to Keele. But we've seen the spark sometimes when perhaps a business leader can see how they could apply some of the concepts of which we've delivered at Keele into their own network. Some of the international guests that have come to Keele have actually taken away some of the projects, and for example, our high-deploy hydrogen project that's gone and been delivered almost immediately over into Kashmir in India, following a big delegation of Indian guests to Keele. So we've seen our footprint, from our sustainability has moved around the planet quite quickly. Just next slide, please, if that's okay, Matt. So the SEND project itself, and these are the figures that we reported to the Department of Levelling Up at the end of the programme. So we saved 13,000 metric tonnes of carbon, and that was against the baseline we were given. Supported 273 small to medium-sized enterprises with projects and knowledge exchange. For us, though, what we started to see was an opportunity around job creation. And some of the businesses that we started to support, we started to see quite sizable growth. So we counted at the time around about 150 jobs. I think we now know we're past 400, but we can see the development of the project growing and its footprint growing as businesses expand and grow from the information that was provided. But the delivery of the system at Keele, it wasn't just a case of implementing the software as it sort of seemed to have been described by Matt. Actually, it took a huge amount of programming time, not just from Siemens, but from our own team as well. So Siemens alone put just over 31,000, it's probably past that now, 52,000 hours worth of programming time into developing the system. The visitors this point last year were 2,000. We're now just over 3,000 visitors. But from an academic perspective, 32 journal papers, 17 conference papers, 16 PhDs, a whole host of MSCs that have gone through the programme. So we can see how this has supported the university, but also supported business from academic and research projects, which has been absolutely amazing. What I'm hoping to do now is sort of pass over to India so she can talk about some of the student journeys and some of those projects.
Mm-hmm. Thank you. Right, so as you saw from that last slide, we had a mix of PhD projects and MSc projects. So initially at the beginning of the 4-year programme, we started with 3-year PhD projects, both internally to Keele, and then also we funded projects which worked in collaboration with other Midlands universities and businesses. I'll go through a couple of them later on. What we noticed from businesses was the PhD projects, those 3-year projects, were a little bit too long for the needs of the companies. And what feedback we were getting was for shorter interventions. So we reduced projects down to kind of 3 to 6 months, and that's fitting with the MSc projects that we were running at Keele. And then even further on towards the end of the project, again, we're receiving requests again for even shorter projects, sometimes only kind of 70 to 100 hours. So a real range of project durations, a broad range of subjects and topics, and I'll discuss a couple of examples in a minute. Basically, the pie chart on the side, you can see the kind of the degree subjects that our researchers came from. the PhD students at Keele were predominantly computer scientists. A lot of those projects were highly kind of data-driven projects. And then looking at the MSc, again, we took students from computing, but a big bulk of them were also from the MSc in environmental sustainability and green technology. And it really aligned with the content in that course, and it was giving them extra opportunities for that consultancy experience. So in terms of the projects and the recruitment of the students as well, it was a competitive project. They were paid placements. It was the students had to apply as they would for any other type of placement and any other type of kind of job or part-time role. They'd submit an application and conduct interviews with the employers. Those interviews kind of varied. Some of the employers wanted a little bit more from the students. You know, they'd ask for kind of a presentation or a site visit, and it was, you know, a really thorough application process, and that helped kind of pick the right student that would be able to work with the company well and deliver the outcomes that they wanted. So in terms of the kind of the types of projects we did, we noticed that at the beginning, a lot of the projects were around kind of innovation, carbon reduction. And as we went through kind of the pandemic and businesses facing different pressures, and then the energy crisis as well, they were facing additional pressures from that. The requests from businesses were changing from that innovation, that carbon reduction, to very purely, our energy bills have doubled and tripled. Can you support us with, you know, looking at our operations, sustainability within our business, and asking the researcher to kind of do those feasibility studies, do sustainability audits. So we really noticed that clear switch from the business requests, and we responded to that. So like I said, we responded with those quicker, those shorter projects to try and meet those needs. But the students were still, you know, they were gaining a lot from that. They were still project managing, consulting with the business, as they would with the longer kind of PhD project, but it was condensed into a much shorter time frame. So as you can see on the bottom, these are kind of some of the benefits that our students gained from it. And I can speak from my own experience. I completed 2 of the 6-month research projects with businesses. And I really found it beneficial. On top, I completed my MSc 2019, 2020, so right in the pandemic year. So half my MSc was at home. I didn't get to do the kind of the lab-based dissertation that I wanted to do, or do any kind of employer engagement through my MSc. And I felt like I'd missed out. But the SEN project offered that kind of that extra experience that I could do. You know, I could still work remotely. I'd have regular meetings with the business, and I was managing my own project that way. So I still felt, you know, I gained that experience that I felt I'd missed out on during that pandemic year. So I could apply knowledge from the degree, explore topics in greater detail that I'd learned in my MSc. My projects were kind of around hydropower and battery storage, which I hadn't really delved into as much detail during my assignments during my MSc. So it was a really good opportunity to, you know, research and explore those topics. And similar for other student researchers as well, you know, they were really keen to explore something that they hadn't kind of delved into as much during their MSc. We all had opportunities to present our research, both to the employer during regular kind of fortnightly to monthly meetings throughout the projects, but also to kind of, you know, senior leadership team within Keele University and to other students. So there was a lot of kind of presentation skills and opportunities to do that. You know, each student research had to produce a bespoke report for the SME, as well as other material if we were asked. So, you know, presentations that they could then use in their communications to other clients or something. So, you know, there was that different skill. So some students, you know, maybe needed a little bit of extra support about how to write for a business and for a layperson, for example, you know, switching from the mindset of an academic piece of writing to a business piece of writing, which is a really important skill. So we worked with the students to, you know, develop those skills as well. And also just increased confidence. So a lot of the students might not have had any experience like that before. You know, it was a first time consultancy experience. It really gave them confidence to then look for graduate employment. And most of them, you know, they referred back to that SEND project experience in their interviews to help them secure those jobs. They could, you know, talk about the project management skills they'd gained, how they, you know, employer engagement. And that's, you know, the type of skills that businesses are looking for, they were able to gain during this project. So just give you an example of some of the projects. So one of the external PhD projects, which was with Aston University, and it was Adelan. So they were looking at solid oxide fuel cell development and the Midlands supply chain development. One of our Keele internal PhDs with Aztec IT Solutions was looking at digital twins. Some of the kind of the 3 to 6 month MSc projects were looking at micro generation renewable power, but it was a broad range. So we had one company which was a mobile phone repair company based in Newcastle under Lyme, literally down the road from Keele. And they were looking at the second life application of lithium ion batteries and mobile devices. And basically they were looking at alternatives to the mobile manufacturer had a policy where if a screen was broken, they had to discard the battery, no matter if it had been a 1 day old battery, the battery had to go. So what this student worked on was, you know, to look for alternatives. Was there a process that could be undertaken where the screen could be fixed and you could save the battery? And they worked on that with TMT first and the mobile manufacturer, and the mobile manufacturer actually changed their policy. And that has then, you know, saved around 100,000 mobile phone batteries each year just in that one mobile phone repair company. And that's now being scaled out nationwide and globally in other mobile phone repair places. So that project's all around, you know, e-waste, which we all know is a massive problem, around, you know, circular economy, and making sure we extend the life of technology that we've got, and we're not just discarding those kind of critical materials unnecessarily. Other projects was around looking at life cycle assessments of alternatives to Portland cement, you know, heavy carbon emissions from that material, and they were looking at an alternative for that. And then on the next slide, I've got a video from another company based in Newcastle, which is looking at resilient power supplies for remote base stations for another mobile phone company. So I'll just play this, Matt. Apologies if it's a little bit glitchy. Hopefully it'll.
With one of our key clients, Vodafone, we were asked to look at options to reduce carbon emissions from the various data centres dotted around the UK. Keele University, it's no secret, is a world leader with sustainability, carbon reduction, and support in academia.
We looked at different sites across the country. So there was different altitude in the sites. Some of them are very north, where possibility of using renewables quite low, and then we moved to the south with this abundant opportunity to have renewable sources.
Shujal was able to get hold of more information about the energy usage, the diesel consumption, and then really started to explore how alternative technologies could be used. The final outcome was really great, because not only was it a document produced by KWA, but it was produced in conjunction with Keele University, and that just allowed that report to carry so much more legitimacy and so much more weight. I'm just delighted that so many intelligent people are looking at a way of answering that problem. This project has been fascinating, but it has been very specific to data centres, replacement of diesel generators. It's really been a catalyst to start looking at how we can apply some of those principles to other projects that KWA are carrying out. Would we work with Keele University again? Yes, definitely. It's been a very, very positive experience.
Okay, so just before I go into this, so just some of the other kind of companies and sectors we worked on these research projects, you know, they included kind of microbreweries, included looking at leisure centres, housing and architecture, heavy manufacturing industries such as ceramics and metal fabrications. It was a real wide range of companies and businesses, some with kind of similar challenges that they wanted us to address, and others a bit more kind of bespoke to their business. So it was a really interesting program. I know our team learned a lot from talking to these businesses and being involved and supporting the students through this. You know, it was a real collaborative effort between not only kind of our project management team, but also the academics and also the members of our estates team as well, bringing their expertise together to help support the students, support the employer on the project. Yeah, that's quite wordy, but that's some of the feedback we got from the students, you know, how they've said, you know, it's really helped their current job. They've helped them secure their jobs. They learn really key skills on top of their MSCs, and going forward, it's been worthwhile experience for them taking part in this project. Next slide, please. And then just to kind of finish, this is just what our final offers are. And Julian, please jump in if you want. But obviously, as a university, we've got opportunities for research, student placements and projects. But we also have skills boot camps in net zero and smart energy transitions and place-based decarbonisation, which is run by one of our colleagues. And that's open to West Midlands employees, 16-week boot camps funded by the West Midlands Combined Authority. And yeah, there's more information on our website for that. We also have a climate ambassador program. The regional manager for the West Midlands is based at Keele University. Again, another of our colleagues that we could put you in touch with. And that's around kind of engaging with businesses to volunteer their kind of expertise to support schools in developing climate action plans. So yeah, big program to get involved with if anyone is interested. And I think that's it.
I think I'd just like to add in that I know we've delivered some absolutely, truly amazing technology at Keele, and we've worked on some amazing research projects with the businesses. But what has given me the most satisfaction has been watching the student journeys, and you know, on a sort of week-to-week basis, I'm still receiving reference requests, and you know, can I help somebody to you know, find the next employment opportunity, and would I mind, you know, signing that reference off and giving them that opportunity to move into some even better employment. And they've used the SEND project as really their initial starting point. And you know, they've done some terrific education, come to Keele, delivered a project, had the opportunity of some commercial experience working as a consultant, and then gone out there, you know, into the industry sector. So we've seen the SEND project as a total has delivered some absolutely incredible opportunities for both research to business, work for, you know, students, and actually credibility for the university and operation in this sector. So really proud to have been involved in it, and the team members which have been involved. So it's been brilliant for us. Thank you.
Yeah, so I think the final slide was just any questions slide. Oh, and that just I'm proud of that. So
that's key, isn't it? The Green Gown Award connection. So congratulations on that. I know a lot of great work came out of that award in 21, and hopefully there's some traction here at the highly commended from last year as well. Thank you all for a really great presentation. So much in there. I was very, very fortunate earlier this year to come and sit for 10 minutes with Julian while he showed us all the really cool things that this was doing. And actually it was Matt, I think I sat with. And I don't know a hell of a lot about energy, but it's amazing how accessible it was and how easy it was to kind of understand what they were doing and to kind of really just connect with some of the work they were doing. So that was really interesting. So yeah, if you've got time or you want to head up there, they're very accommodating to let you come and have a look. Does anyone have any questions? I can't see any in the chat, but there is an opportunity now. Adam, I'll get you to pick us off with the first question.
Yeah, thanks, Claire, and thanks so much, guys. That was again really fascinating. I've seen sort of variations on the same theme, but particularly India. Thanks very much for the student perspective. I've probably not seen it from that angle before. So first question, really, just to build on that, how, I don't want to call them the average student, how do the non-energy transition specialists engage with the SEND project? Do students of Keele understand that they're sat on something quite groundbreaking? How do you ingrain it in the wider sort of experience of those perhaps not directly involved?
Yeah, so if I start with kind of, so obviously there's very kind of relevant MSCs already, and part of us being a demonstrator site was to, you know, those new cohorts of students, we'd invite them on tours of the energy park. The way of engaging kind of those in other degree courses that may not have any interest in, you know, we have an annual kind of green festival week, although it's kind of extended to a month in March now, and that's where we, along with a bunch of other sustainability events and talks and initiatives, we include an energy park tour, and that's where we kind of encourage those other students to, you know, visit it, because it's a little bit tucked away, kind of the back of the campus. It's not really somewhere that the majority of students would walk down to unless they were interested in it. So that's an opportunity for them to see. But there's been kind of, you know, physics students, those academics will bring the physics students. We've got a new BSc in physics and renewable energy, so we bring those students over. Computer science students and data science students are interested from that data aspect of it, and they'll bring those cohorts of students over. But there's still kind of, you know, there's still work to do in terms of engagement around even, I would say, even Keele staff, you know, not really knowing how the energy is managed on campus. And it's just, you know, it's just something that's kind of there now. You know, they know there's a wind turbine, they know there's solar panels. But I think there's still more work to say about the whole, you know, all the control and management that Matt does. And Matt does a lot of tours and a lot of talks about that as well. But yeah, not everyone knows about it, even on the campus.
I guess you know, the glass half full. I guess the positive side of what you've just said there as well, the fact that it just works, it just happens, is to your guys' credit as well. If it were breaking down all the time, then I suspect they would have been engaged, but in a lot less positive way. But it sounds like probably without you knowing, you're developing advocates for this type of scheme. And I guess like most of us, when we left university, it's only after you've left you realise, you start to look back and you start to remember some of the things that you perhaps were exposed to, which you probably didn't take as much notice of as you should have done. And thanks again.
Any other questions? Helen, would you like to verbalise your question, or shall I read it out?
I can verbalise it, that's fine. Yeah, thank you very much, everyone. It's really interesting. If you didn't know before, we all know why you won the Green Gown Award now, so thank you very much. It's just, yeah, obviously I work quite heavily on the Green Gown Awards. The ethos is to share best practice within the sector. You've given us some really good information on what you are doing with other businesses, consultancy work, student research, etc., and also supporting next generation students. Just wondered, from a institution point of view, have you been approached by any others to implement similar types of projects to SEND within their own institutions?
We've supported organisations like Birmingham University and Cranfield University in terms of their thinking and how they would like to adopt and introduce systems. We quite frequently receive guests, and I think the main question that business guests come to Keele for in the first place is actually trying to understand the technology in an environment where they're not pressured to make a commercial decision before they start the thinking and start to make that considered view. So we find ourselves quite frequently working in that early development stage with organisations before they set up and make those technology acquisitions. Find ourselves working quite actively with many local authorities as well. So we're in that space where we do support where we can, but clearly there's a limit that we can deliver in that space before it becomes consultancy.
Thank you.
Great. There's a question here from Guy Head from Exeter. Your SEND project started in 2017, 7 years later, and you've achieved an exemplar project. Did the snowball effect of the scale and the novelty of the project enable the slow stakeholders either planning to move to your timescales?
Missed part of that question, sorry, but I think that the snowball effect that you were talking about is the technical challenges that we were starting to face in the procurement, the acquisition of planning permission, the acquisition of grid space, which took a lot of time to deliver, and the connectivity. And when you look at the 31,000 hours of development time to bring the infrastructure together, that's what took the time to bring forward the planning. We, as a team, really saw the impact of this once that infrastructure was in place. And when that translated into gas coming to Kiel, that then translated into projects and research opportunities. So the latter parts of SEND, where we were actually delivering all the research, delivering all the student projects, is really where the project came to life from our perspective.
And there's also an element of just kind of the novelty and the momentum grew, and that some of the stakeholders, for example, your planning departments, that kind of maybe not weren't on board, were kind of caught up in the momentum of the novelty and the scale of it and the pace it was going.
We've seen different stakeholders, and we were tasked and challenged to work with, because of the funding that we were given by BASE and the Department of Levelling Up, to work with initially Staffordshire small SMEs. But we were seeing global players coming to Kiel and asking questions around how do they do this, how do they make these connections. And as a small team, we were having to focus on our local and regional delivery. And it's now post the SEND programme where we're starting to work with some of the big international players on projects, and how we can actually work with those players around anything from environmental sustainability all the way through to energy. And these are the benefits which are coming from the project, arguably 2 years on since it completed.
Amazing. I have a quick other question. Adam, I'm going to preempt you. Just in terms of, you mentioned some of the international work that you're doing and some of the institutions that you're working with. Now that you've kind of, when you say you finished the project, but obviously it's an ongoing initiative, is some of that work that you're doing on an international basis, or is it mostly sort of UK based? And is it with institutions or with other partners?
We collaborate with other universities, so we've been, across the Midlands region, we work as part of the Energy Research Accelerator and collaborate with other universities on research projects. But typically, we host departments of business and trade visits, and we've started to collaborate as a result of businesses looking to develop their footprint overseas, and recognising that actually what's required is the skills that go alongside UK trade abroad. And so at this moment in time, we are developing an application to the Ayrton Fund to support the energy transition of Sri Lanka, for example. That's something we're working on at this moment. And that's part of the work we do. But at a local level, we host the climate change group. We support a regional COP, which we were discussing this morning. So there's all activities that take place from a local level all the way to sort of international activities.
Great. Adam, I jumped in. Do you want to ask one more question before we close off?
Claire, it was one for Matt, and it's going to be really unfair in the last 30 seconds, so I might drop you an email, Matt. It was just SP5. I was really interested in how the system is clever enough to know when it hits constraints or sort of maximum limits to put into battery, to heating. As I say, probably unfair in 30 seconds, but it's just how that system is how it knows where to direct the energy when you hit those constraint limits?
So basically, we've got a user configurable parameter for the dispatch of the demand response assets, so we can change the point at which those assets are dispatched. So at the moment, we've got it set at 500 kilowatts. So at that point, that is when it starts firing up the various assets. The reason we've got it user changeable is because it's a real fine balance. So we want to utilize as much of that energy as we could without curtailing the solar, because as a last resort, if we've turned on everything we can and we are still breaching that export limit, we have no other alternative but to actually turn the solar down at the inverter, and you're just wasting that energy then. So we try and keep as fine a line as possible and keep as close to that 1.5 megawatts as we can, but without breaching it. So once we hit that 500 kilowatts, we start dispatching the assets. That's being constantly monitored. If we don't come back down below 1.5, then we curtail the solar. And again, that's pretty much instant. So the solar will be turned down to make sure that we come back down below that level again.
Thanks, Matt. Superb. Yeah, probably the same challenge we face nationally in the next probably 5 years. So again, really interesting response. Thank you.
No problem.
Amazing. Thank you so much. We're just out of time, unfortunately, because we could probably carry on for another half hour at least, because there's so much in this. But thank you so much for your time. And I know that you are happy for people to kind of come back and ask questions. So if anyone has any further questions or wants to get in touch with either us or with Keel, then we can go from there with questions. Thank you very much for Tech for making this all happen today. So really appreciate you, your sponsorship of the Green Gallons, but also just helping us to showcase and share really best practice across the industry. So thanks all for coming, and hopefully we'll see you quite soon.
Thank you.